begin to get the sheets over there?
Yes.
Everybody got the sheets? Okay. So, for those of you that are a little confused, or for those of you that weren't here, we maximize and we minimize. Whatever we maximize or minimize is going into your Y1. Generally, we're minimizing a sum and we're maximizing a product. And you'll see why today. We kind of looked at it a little bit yesterday. So you have two numbers. So you're going to have two let statements. We had the let statements for the first one that I said carried all the way through. This was your first positive real number. And don't even need that. And let y equal your second positive number. Okay. So this time around, we have a statement that says the product of these two numbers, x and y, is 192. So we write the product, x times y, God bless you, as 192. And the sum, God bless you, the sum of the first one is x, plus 3 times the sum, 3 times the second is the minimum. This is what's going into your y1. The sum of the first plus 3 times the second. Our second one is y. This is going into your y1. That's a sum statement. So we're putting this into your y1. Now, when you put this in your y1, this y represents the sum. These are your two integers right now. Your two positive, not integers, but your two positive numbers. When you go to put this into y1, you have a problem putting in that y. So we go back to our original statement and we say, well, if I can solve for y in terms of x, I can substitute out that y. So I want to say y in terms of x, so I divide both sides by x. And now I can take this and substitute out this y for that value. So I'm going to just put in here, that's my y. Everything else is going to stay the same. So in your y1, it's going to look like this. 3, sorry about that. It's going to look like this. Again, this y1 is a sum. When you find this x, when you find x equals, you're going to come back to this statement, either one of these, and you're going to substitute x in to find your other value, because your y1 is your sum. Are we seeing that part, or is that part a little confusing, using the x and the y? If we don't use x and y, and I've tried it before not using x and y, kids had a harder time transitioning to the x value, because in your calculator, what do you put in? X. So if we use two other variables, they still had to go put the x in there. And then it was even more confusing to do that. So we all agreed to keep the x and the y as our two numbers. Now, the hardest part is in your calculator. If you get a minimum, try to visualize your minimum. Your minimum is going to go like this somewhere, right? Your minimum has to be this. Again, we're only in quadrant 1. You can never have a 0 that an x that is negative. You can never have a y that is negative, because our first original let statement for these first 4 problems were positive numbers. So we have to be in quadrant 1. It had it on the very first page. We use the same let statements for the first 4 problems. Now, putting it in your calculator was probably the challenging part, right? Is that a little bit more challenging? All right, so let's put this in your calculator. I'll just go wherever my board takes me today. You can use a fraction bar, whatever you prefer to use. Okay. When you graph this, again, you're going to start with your window at the 0 for your mins, because we're not going to have any negatives, because our let statement says positive numbers. So there's no negative numbers. Now you have two numbers that multiply to 192. You can go to your table for this like you can graph this anywhere. You won't see, if you don't see it, don't worry about it. You can go to your table, start at your zero. What's happening to your y values when you have a minimum? They're decreasing, and then what? They're increasing. So if we find the halfway mark, we should be able to double that for the x. If we find the halfway mark too, that's just your y minimum. We'll just make it a little bit more than that. So we come down here, and we're decreasing. Now remember, we're just getting a window. So we don't care when, like exactly where. And I could see I'm dropping down, and somewhere over here, didn't I start increasing again? Somewhere. So that's okay. I'm going to take this number right here, 29. And I'm going to take 29 and double it. I don't need to know exactly where, because I'm going to do a minimum or a maximum. So I just double it. And my maximum probably was close to where my zero was. Somewhere up there. Okay, so we said 58, 59, I'm going to double it. I'm going to just make it 60. Don't sweat this out. Don't be exact on this, because it will drive you crazy. I'll make this one 60. And now let me see what my graph looks like. I can see it, right? I can see my minimum. If this bothers you, make your y a little higher. It's not really necessary, because you just need to find the minimum. So if I want to make it come down a little bit more, I certainly can. It drops a little bit more. Sometimes what happens in a minimum, this is actually because of this. This is your, I forgot what they call these. Like your inverses, like when one goes up, the other goes down. So you actually have two parts to this. You have this part, you have this part down here that goes down. If you can't see the sharpness, here's a good way to get it sharper. Take your x and increase it. So now, it's going to make it a little bit sharper on my minimum. Yeah, and that might help you find your minimum a little bit better. If you want to just guess what your window is, you can't hurt your calculator. You can't do anything wrong. If you find your window is so messed up, just go back to Zoom 6 and start again. Then go to your table and see what you find in your table. Today when we do applications, the numbers are going to be a little higher. So we're going to have to play with them a little bit. Again, do a minimum. And if you want to set your numbers from 0 to whatever, or you want to go with your cursor until my screen flips to the other side here. Okay. Go past it. Go past it again. It doesn't like when I hit it too many times. Okay, remember this is where it's looking, right in here. So get your minimum. We're going to round to 3 decimal places. That 999 really is a 24. So your answer here is 24.48. This is your minimum right here. This 24 is your x value. What does this 48 represent? My y1, which is what? My sum. So now, if you want to find your other value, you bring that 24 over here, you plug it into here, and you find what your y is. This is your sum right here. This is your x value. Plug it in and find your y. And here's your answer. This is all I need for a sketch. If I say sketch, this is all I need to see, that you have a sketch. That you show me that it's a minimum. That you show me it's a minimum versus a maximum. Okay. Clear up any issues? Yes. Yes, yes. The cat is right up there. You guys that were in here, does it make a little sense? Yes.
What's the point of finding y1? Like, is there any reason, like, does the 48 do anything?
Well, how else would you be able to find x and y? You have to be able to put it in your calculator somehow.
Yeah, I get that, but
yeah. Well, sometimes the calculator will say, where's the minimum sum?
oh, okay.
Yes. When we get, these don't really make that much sense. When we get to the application, the sum is actually the perimeter of what we're doing.
Oh.
So they will say, what is the perimeter?
Okay.
Yeah. I like I said, you won't see it right now, but you'll see it when we do today's. We good with this? Okay. And this one was very similar, but we did, I have the whole thing here. So we did a maximum on this. And the maximum says, this is what's going into my Y1. So my maximum says, put your product in your Y1. So your Y1 is going to say X times Y. Again, we have the same two left statements. First number, second number, positive numbers. So now I'm getting a maximum, and I expect it to look like this and to turn. Okay, so I do the sum of the first and twice the second. The sum of the first and twice the second is equal to 100. I'm right here. And I say the product is a maximum. So I go to my Y1 and I say my product is a maximum. I can't enter that Y in there. So I come back to the only other piece of information I'm given and I solve for Y in terms of X. Subtract your X, divide by 2. You don't have to reduce this. Leave it like this. Just put it into your calculator like that. Plug it in here. Substitute it in. Excuse me, and you should be able to find it. If you have two numbers, the sum of the first and twice the second is 100. Even if you took 100 in half, there's your X value, 50 and 50, right? You can go with, like, make your X be 100 and see what you come up with. You can play with your windows based on your scenario. Hopefully today the scenarios will make a little bit more sense because, like when I showed you yesterday when we do a rectangle, perimeter versus area, you want to maximize area, you want to minimize perimeters. So it's going to make a little bit more sense for you today. Try this if you didn't try this or you struggled with it, and it will probably answer Gabby's question of why do we need to put this in our Y1. So now, we're going to kind of do the same thing here. Consider a rectangle. You probably have enough space on yours, right? And we'll verify this one algebraically, just so that you can see it. So we consider a rectangle. So first off, we're looking at a rectangle. The length is X, and it has a perimeter of P. Okay, we're going to express the area A as a function of X and determine the domain. Now, they didn't give us a value for your width. So since we're using two variables, I'm going to use Y for the width. Is that okay with you? So again, we're going to have let X equal the length. Now you know why we say in the other ones, positive integers. Well, these are going to be positive, not integers, just positive numbers. You can't have a negative length, you can't have a negative width. When we look at a scenario like this, this is going to make a lot more sense to you. So we're going to use a graphing calculator to find the area. We're also going to graph blah, blah, blah. And we're going to maximize our area. This is key. As soon as you see the maximize or the minimize word, that's what goes into your Y1. So start like this. Y1 equals area. How do I represent the area of this rectangle with the side of X and Y? X times Y. I generally like to keep the Y1 so you see the Y1 is different than your Y. Alright, so they gave us this, that the perimeter is 100 feet. What is the formula for perimeter? Side plus side, so 2L plus 2W. Can we write it like this? Could you even write it like this if you wanted to?
Yeah.
Or L plus W plus W. That would be a little longer for us, but is it okay? Which one did you want me to use?
The easier one.
The first one. Okay, you guys are comfortable with this. So we have this. So where does my X go? For the L. And my Y is going to go for the width. Okay, so now, in my Y1, I need to substitute out that y, because that y, I can't type that into my calculator. So for this y, I come back to this statement and I solve for y in terms of x. If you wanted to at this point, could I divide everything by 2? Just to make life easy? All right, so the numbers aren't so large here. Do you have to? No. So I'm going to subtract x and plug that in. Now, I'm going to substitute this y into that y. There's my y1. This is my area. I'm going to do a little sketch. I get a maximum. So am I opening up or down? Down. So all I need from you guys is this, that you're opening down, and you're going to get a maximum point here. And we're going to get an x and a y1 right now. Okay? So we're going to put this in your calculator. You put it in yours, and hopefully I can get it in mine here. This is not always a handy-dandy calculator. Okay, I'm going to see if my original screen works for this, and it doesn't work for this. Because what is my area going to look like? A pretty big number, right? If my perimeter adds up to 100, so even if I figure 25, 25, 25, 25, just to kind of figure that out, what is 25 times 25? A lot more. Like 6,000 or something like that. 30 times 30 is 9,000, so let's say 6,000, somewhere around there. So maybe I want to put my window.
It's 625.
It's 625? Oh, okay. So I was pretty far off. So let's say 700 and see if that works. So I've made it be 700. Do not worry about making your windows be exact. And your window doesn't have to look like my window. All you have to be able to do is to find a turn. Okay? I figured, max, if I thought 25, 25, 25, 25, if I double it, because I'll only see halfway if I do 25. If I put a 25 here, I'm only half of my curve. There's half of my curve. I really want to see it turn and come down. So play with your windows. Get used to playing with your windows. If you struggle with the window, remember, you can just go to your table. You're increasing, decreasing. You start at the 0, you're increasing. See this increasing? You're going to go until you decrease. Do not worry about finding the exact point. Just pass the halfway mark and double that for your x value. And then for your y, just round it off somewhere. So we've got this. Now just find me a maximum point. So find me a maximum. Is everybody able to get it in their calculator?
Wait, what's the point of finding where it's decreasing?
Because if you can't figure out your window, if you can't find your window, you can go to your table and you say, if I'm looking for a maximum, my y is increasing, and at the turning point, it starts to decrease. So I'll know halfway through my graph, and I'll know my y max. So if I'm looking for this, I'm watching my x increase, and then I notice, whoa, it started to decrease. So I just stop right there. I take this, let's make it 30, double it, and make it 60 for your x, and somewhere around here, make it 650. So I come to my window, I say, okay, give me 60. Give me down here 650. And that should do it. I should be able to see my graph turn. Your window is just that, a window of opportunity, if you will. You do not have to be exact on those things. Your max and your min will get you your exact point. Okay, so anybody find me a max? 25, 625? Okay, so this is my x. This is my y1. What does my y1 represent again? My what? My product. My product. So now, to find that x, I have to bring this x in here to the simplest space, and y is also equal to 25. So I have an x of 25, and I have a y of 25. So we're kind of seeing a little pattern here. We're very, very close to being the same things, or if not the same things, right? We're kind of seeing this. All right? Everybody okay with this? All right. Oh, let's verify this algebraically. I wish I could put this in here. So now, we're going to verify this algebraically. I just put this backwards. All right, now, if you do this, your turning point here is where we can complete the square, right? And find our vertex. If we can put this in vertex form, shouldn't we find the turning point, the vertex, where it turns? Wouldn't that be our maximum? So if I complete the square on this guy, hang with me for a minute. We're going to complete the square. Factor out your -1. And we're going to minus something. This is an x. Sorry, I have a very little space. What's half of -50? -25. What is 25 squared? We just did it, right? 625. Then I'm going to come out here and subtract 625. So this gives me, my -1 tells me, what does that -1 show me? That my parabola turns which way? Down. So I end up with this. Y is equal to -1, x minus 25 squared minus, whoops, this should be a plus. Sorry, this should be I'm minusing a negative, so this should be a plus. My writing is so sloppy. Let me put it over here. So we end up with this. Because when you subtract, we added in here, we have to subtract. We have to take this and multiply it by a -1. I lost my -1. Here's my -1 out here. So when you multiply 625 by a -1, you get -625. So a negative minus a negative is a positive. I just lost my negative sign. So what is the vertex of this graph? 25, 625. So it works, right? Isn't that my turning point? Wouldn't that be my maximum point? My x would be my maximum, my y would be my product. Okay? Sorry, it's a little sloppy down there. I'll shrink this down a little bit more and get a little bit more space for the next one. But these are doable, right? Isn't it much easier on your calculator? Much easier. All right, let's try another one. I think the next one is a minimize. Nope. The next one is same thing, isn't it? Same thing for the perimeter of 36, not a minimize. All right, I'm going to leave that one for you guys to do. I'm going to leave you 6 to do. It's the same exact problem. As a matter of fact, why don't you guys try it now? Substitute this in. Chris, how did you substitute it in?
I did have divided by 2.
Okay, you divided this by 2. Do you have to? No, but it just makes it a smaller number, a little easier to work with. I won't have a fraction in here when I go put it up here. And be careful on your fractions with your parentheses if you don't use your alpha keys. Okay, so then what? Subtract x. You're going to solve for y in terms of x. Good. Now, then what am I going to do with it?
Negative 11 for 1.
Thank you. No, that's okay. Probably didn't hear the no part. So y1 is equal to x times 18 minus x. Could you use the same screen as we used before? Did you find you could?
They're smaller.
I made it a little smaller because you still see the turn of it and find the vertex. That's what your goal is. You could use the same screen as you had before. It still appears on there. It maybe looks a little smaller. If it upsets you, change your Y, change your X. Get it a little closer, but you need to find a turning point. Okay? Let's see if we can squeeze in number 7. Oops, I did number 7, so I'm going to have to do this. Find the length and the width of a rectangle that has an area of 64 and a minimum perimeter. So this is what's going in your Y1. If it's a minimum, which way is my graph going? Going up. So somewhere, and we've been noticing that they kind of have a little slant to them. This is my minimum. When I find my X, Y1, this is going to be my perimeter. Okay, so my area. What's my area formula? X times Y. And my perimeter, this time we'll put this in here in your perimeter. So somehow, I have to get that out of there. So what am I replacing? Same process. I'm going to replace what? My Y with what? 64 over X. So this is your perimeter formula. Leave it just like this. You don't have to distribute it. Don't take any chance that you'll make a mistake with it. Leave it just like that. If you do the 2x plus 2y, still just replace your y, you're fine. Why did I say minus? I don't know, because I'm talking and writing at the same time. My thing is, if you did it this way, 2x plus 2y, just replace the y. You can do it that way as well. As long as this is your perimeter formula. Okay, so now, put it in your calc and find me a minimum. Same thing as the other one. Let x equal, we're on the same ones for that. Let x equal the length, let y equal the width. I think this is the last of the rectangle one, and then it changes. You go back to a rectangle a little bit later. Did we get one? Could we even use the same window that we had before? It's a minimum. Did we get a minimum? What did we get? 832. So 8 represents my x value, and 32 is my perimeter. What's my other y value when I plug it in here? 8. So I've got an x of 8 and a y of 8. So you kind of see what's going on when we maximize and minimize? Aren't they pretty much coming the same? Okay. Don't do 7. Do 8, 9, and, I'm sorry, don't do 8. Do 9 and 10. 8 I'm going to save because 8 works a little bit differently, and I don't want you to be confused. And hang on, in this bracket, I'm going to tell you which ones to do in this packet. Give it 1 minute. You're going to have to work with that first. Guys, in this packet, just do number 3 and number 5. In this packet, 3 and 5. The second one that I gave you, 3 and 5. 8, 9, and 10, and 3 and 5. 9 and 10, and 3 and 5.